My name's Anthony, and today this is our part 2 of a CAD CAM workflow. Before I worked here at LPI, I did work with other fabricators that fabricated stone, quartz, Decton and the like digitally, and I've worked in the field with these lasers and captured a good number of templates out there. Across a pretty wide range of different styles of projects, whether that's remodels or new builds or high-end commercial fancy stuff, or condos and multifamily where we got lots and lots of units. So today, this session is going to be focused on advanced workflows, specifically if you're using CNC routers. It's going to be a lot of the questions and things that we have about the tool set that exists in LT3Raptor. Okay, so LT3Raptor was built to streamline that template from the field and create a full workflow that reduces labor and the time needed to produce those CAD files for saws and routers. And for many shops, the CNC programming work, it's a big bottleneck in the shop. And traditionally, the CNC manufacturers taught how to take one DXF from the template and take that and split that into the different types of files for saws and routers. And what we'll see today is that we're going to try and take one of those template files and use LT3Raptor's tool set to automate that split, okay? So LT3Raptor is a CAD platform, and specifically it's not a CAM software, okay? But we're gonna take a look at that tool set and see how to bring some efficiency to that programming, okay? I'm gonna recap this meeting that we did last week, just kind of touch base, and we do have last week's kind of part 1 that leads into this live on YouTube, so you can watch that again later. We want you to start with a production-ready drawing from the field, right? If your field personnel are taking all the guesswork and coming up with a production-ready drawing, it leads to fewer remakes and fewer questions, okay? The next thing we did last week was we took that production-ready drawing and we made a couple production-friendly revisions, okay? We exported the paperwork for your customers in the shop, and we created a CNC Saw page. This merges the different template pages into one drawing space and purges dimension lines, cabinet lines, and some of those things. Just a quick prep tool, and lots of fabricators are using that to quickly create the geometry they need to go into their CNC saws and routers. So we're gonna take that feature and use it in a little bit of a different way today. All right. We also spent some time beginning to look at settings that are available in LPI Cloud, right? We looked at job workflow, edge style sets, and how those colors are the LT3Raptor edge styles, which is CAD layers that have meaning attached to them. And that powers a lot of those repetitive tasks, okay? We also looked briefly at the CAD export settings, and we introduced the idea of machine profiles. So you have the template, the CNC Saw page, and today we're gonna look at some of the nesting tools. And each of those has its own, the ability to control those CAD export settings for each output, right? And last, we printed some StoneTags. We had that printer over there. And we'll try and do that again at the end of the day today, okay? So again, this training is centered on the tools that can automate the work for saws and CNC routers. What we're gonna go over is how saws and routers actually kind of want different things, and the big time suck that happens when digital fabricators, traditionally they'll start with a saw, and then they'll add a CNC router, right? And there's just a fair amount of editing in those drawings to take a shape that was going to be a defined size. Let me go off screen here. Just a little sample piece, right? If the saw was going to cut a specific size, right, and it's going to go on the router will finish each side and have to take material off. So now on the saw, we need to make that bigger everywhere so the router can remove that. So we're going to add that into our workflow today, okay? We're also going to do something different with our CNC Saw page. Instead of going to the saw, we're going to play with a workflow where we use that to feed the router, okay? We're also going to look a little bit at a deeper level of the LPI Cloud Settings. We're going to go deeper into edge styles. We'll talk about blade kerf, material offset, and show you where to set up the CAD layer names. There's a lot of power here in building automation, right? Whether that's auto styles and things like that. Now, we aren't here to teach that today, but I want to show you how you can build that workflow. Okay? We'll get deeper into the CAD export, right? We'll talk about the difference a little bit between a joined polyline and some of the mirrored settings. And then print another set of StoneTags that are a little different than the last class, okay? If you haven't yet, I'd have you get LT3Raptor open. If you go to the Knowledge Hub, which let me switch my screen here. I'm launching my software. In the Knowledge Hub, sorry, I need to do a quick thing here. I have a security feature that most of you won't have. And this changes every several seconds. So it doesn't matter if someone sees that, I think. All right. Okay, so I'm on LT3Raptor's homepage, right? If you come down here in the Knowledge Hub, if this panel's turned off, you just hit this button in the upper corner, right? Opens this panel, and we have a group training download, right? This will take you to a Google Drive. There's a zip file, download the zip, unzip the zip, and then come to import job, right? So I'll give you a minute to work on that, okay? Getting LT3Raptor installed wherever you're doing CAD CAM work, I think is really helpful. We recommend that, right? It's just gonna save you time, right? It's a lot easier than shuttling around like USB drives and all that stuff that we used to do back in the day, or emailing files around, okay? So, as we jump in, I wanna pull up a little quote that I came across yesterday as I was putting this content together. And really, I want to give a little context first that for me, measuring in the field, working in shops, doing CAM, CAD work, when I was able to see an early version of LT3Raptor, I got really excited because of what it could do here and how the team that put LT3Raptor together, they were able to solve some of those time-consuming problems by really stepping way outside of the traditional process and coming up with something new. So here's a quote from a famous architect: "You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete." This is from Buckminster Fuller, who's a famous architect. So and for me, this is very much how the problem of programming, and it's how time-consuming that is, it really does get streamlined, okay? So what I want to talk about next, let me switch over here. At the end of the day, the saws just cut the shapes, right? So let's talk about a saw wants a simple, closed polyline, right? It doesn't really need to know the finish on each side of a piece. It just needs to know how big to make it, okay? So what a saw wants is a specific type of file, okay? When we add a router, like I was talking about a few minutes ago, the change is that we start growing each edge. Each geometry grows a specific amount, and it's going to be different based on the finish, right? So if it's going to go up against a wall, you're probably just running a Z wheel, right, to clean up and true up that edge, the finished edges. And today I'm mainly going to use the example of like a 3 centimeter style project. We might run a T30 tool set on finished edges, and we might run the seam tools as well, right? So on the routers, we don't just want a closed, simple, 0-layer CAD shape. We want to maintain each edge's CAD layer or edge style, right? And that's really the thing that's going to make this faster, okay? So each color we use is a CAD layer once you export out of LT3Raptor. But while you're in LT3Raptor, there's metadata, or that CAD intelligence that we talked about, will automate some of these outputs. So we're going to take a look at those outputs, and then later we'll get into how you control each edge, right? I'm going to pull up something, and this is when I was working with fabricators. I did this myself and tested, and we got this working. I'm going to show a clip of auto styles, right? So these are geometries that are brought into, in this case, Alpha Cam, right? Here's some tool directions, right, that were already applied. And this is just a test clip of what we're doing, right? I've got pods placed and parts on 2 tables, and I go and add an auto style. It looks at the CAD layers, automatically creates the lead ins and the lead outs based on your presets. You could always modify things, right? But this is the big idea, is to take what was many, many steps that you had to do on every single job and automate these things, okay? So this specifically isn't something that we're here to teach, but we want to give you a framework so you can build towards this higher level efficiency, all right? Okay. So I'd like to pick up where we left off on the last lesson. Hopefully in the last few minutes, you've been able to download the little file if you want to follow along, or just duplicate a job in your LT3Raptor cloud. And we want you to just kind of play around with these as we go, okay? So on my screen, I'm going to open up the job here. Okay, and this is pretty similar to where we left off last week, okay? We did some straight seams, and one thing we might do right off the bat is go into draw. And I want to change from the seams that we had before, which were extended seams, perpendicular to edge. We're going to come in and I'm just going to erase those, and we're going to optimize these a little bit for routers, okay? So draw. Seam line, which is just S, would be the hotkey for that if you wanted, okay? We can, put in our tool options here on that seam. I'm just going to click on this corner, connect to the wall, and here, okay? So this will just come out a little cleaner for router work, okay? We still have our part numbers, everything's numbered, page 1, page 2, page 3, okay? I want to back out and do one other thing. I want to show you another thing we could do. I can't change a set of colors while we're in the job, okay? But this is a relatively simple, common set of edge styles. I have this is all the default, except I've added a red callout text, okay? I'm going to pop out of the job real quick and show you another thing we can do. If we click on the 3 little dots, again, can't be in the job. If we edit the job, I can switch from the default edge styles to a machine edge style set. And we'll take a look at this in the cloud later. But this isn't just, hey, what are we going to make? This is, how do we make it? What are the cutting strategies, okay? So this is the list of the edge styles we're going to use, okay? And I don't have a simple blue finished, nondescript, hey, whatever the finished edge style is, because we need to pick, right? So is it eased? Is it a bullnose, right? I could just check right now for the whole job, whatever edge we're going to use, okay? So let's maybe go for a double radius, right, in this case. But everything else is just going to map over to a edge style that has our cutting strategies all kind of built in, right? So I'll save that, okay? And I click into it, it's going to look pretty much the same, okay? If I go to View and our counter edge labels like we saw before, last week, that's there, but now I've got like a tooling code here. Maybe that's how you want to work, okay? I'll turn View, counter edge labels, turn that off again, all right? Now, let's do the CNC Saw page. CNC Saw page, I want all 3 pages. They're all going to get merged into the same drawing space. Lots of different settings here, little helper descriptions of kind of what these settings do are off to the side here. This is a simple starting point, right? So I'll hit create. It looks at all those geometries and separates everything. It makes that nice and easy for us, okay? Something else, I find it's quick to just do it right here. Some people like to wait till kind of the end. Because I want to end up sending this to a router, and typically in North America, we'll finish tops on routers, finish side down. We do have some folks that are coming into the meeting that are either from Europe or Australia and New Zealand, and sometimes they'll machine drain boards in there, so they might finish face up, in which case you wouldn't mirror, right? But I'm going to take the CNC Saw page. We're just going to do a horizontal mirror right away. So everything's flipped over, and it gives us text up in the corner that says it's mirrored, okay? Now, let's get into nesting, okay? There's a couple primary options for nesting. If you're not exporting out to some other vein matching solution, let's say it's a material that doesn't require vein matching, I'd use the Use Slabs for Nesting checkbox. I might put in what type of slab it is. Okay, we get the slab boundaries. Okay, we could not go right to the edge of the slab, but shrink into the slab a little bit, right? Hit next. Okay, I don't want to duplicate everything, and maybe just want this one. Create, and boom, right? It will lay these out into slabs, which is really helpful. Lots of shops are doing this every day, okay? But I want to show you another option. So if we're going to add more than one layout, just like the page bar, we'll come right up here. We'll add a layout. This time we're going to uncheck. This all gets grayed out because that's not what we're going to use anymore. What we're going to focus on is if you're going to some other slab vein matching solution, there's a few of them out there now, really what we care about is the material offset. All right, so I want to show you what this looks like. Okay. Also for cutouts, I want it there. Okay. If we hit next, again, I'm just going to use our CNC Saw page. I could do this and it would effectively be the same. Okay. I'm just, I guess, in the habit of using the CNC Saw page because it's already all merged together. Okay. So both of these style layouts, one, it's fitting these into the rectangles that represent the size of our slabs, or they're just kind of in relation to approximately how they'd fit together. Okay? If we zoom in, we can see there's a little bit of extra geometry there, okay, where per edge type, it's added the additional stock that the saw would leave for the router to clean up, okay? I'll come up to this layout, and again, we'll see that same thing, right? So we see all these kind of extra lines. If we come up to the view, we can even just turn on or off the view. So material offset, Okay, we could turn that on. This is the finished part size. This is the part size as it would be loaded up on the install truck and head out and get installed. But this extra layer, that is what you'll want from the saw. We can turn off our finished final part size geometry and see just the oversize. Sometimes internally we call this the inflate and deflate. It inflates, makes the perimeter of each part larger, and deflate, as in shrinks the cutout so you have extra stock to remove. Okay? So you can always see this in here by turning on and off, material offset and finished. Okay? I'm going to pause here and see if anyone has any questions. Okay? We're going to go into look at what exports happen after this next. I'm just going to wait a minute and see if anyone has questions about what we've gone over so far. Okay. So let's take this and export. So now previously we already did our shop paperwork and all that. Often I'll just come to File, Save to Folder, and export all these files. I hit Next. I just kind of plow through this. Usually I'm just exporting one or the other, but I'll let it export all of it right now. Okay. And based on the settings that we're going to review later, the software is looking at the geometries that exist, and it is giving an output, an optimized DXF output for each of the files that we're going to want. Okay. So it's recalculating all the vertices, blah, 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 based on what we're going to see, which are polyline, closed polyline shapes, and the polylines maintaining the layers, right? So we can go in a CAD folder. We have our original template pages here. Okay, that's right here with all of the original templates. This matches your shop paperwork. Okay, we'll go up a level. We have our CNC Saw page. Okay, so we have the regular CNC Saw page right here, and we also have the mirrored page. I'll go up a folder again, go into nesting. I have each of the layouts. So if we come over here, go back to the nesting tab, we have our two layouts, right? So we have a folder for each layout, right? So if we go into layout 1, okay, there's a folder for each of the exports that I'm going to show you in just a minute, okay? Material offset, which is just what might go to the saw. All layers, finished, finished mirrored. We'll talk about all of these, all right? And what I want to show you is if I come in here, based on all the different needs of different shops and their workflows and things, right? In layout 1, we have 1, 2, 3 slabs, okay? Some fabricators are requesting that we have a layout for slab 1, slab 2, slab 3. We have other fabricators that are requesting, I want one DXF that has all 3. I don't want to import 3. So we have each. So because we have 3 slabs, there are actually 4 files. 1 for each slab, and the 4th, that's all the slabs together. So if you need a slab that has the 0, 0 of each slab, the only way to do that is to give you a unique DXF file for each, right? Today, I'm mainly just going to grab the top one that has all of the slabs, right? And we would just drag that over into AutoCAD, okay? So let me pull this back up. I'm sorry, I just restarted right before this meeting. My audio is doing something weird. So once I relaunch this, I've actually gone in and taken all these different files, and we'll show you what this looks like. I made a big grid. No, not that one. This one. This should be in your zip file as well. I saved this as a DXF. So at first, this looks like a lot, but we're going to break it down one step at a time. Okay. So I'm going to zoom in right over here. These are our original template pages. We zoom in some more. We can see There's the Euro seam. We did a offset with taper scribe line on the back wall. So we see the dash line that was the original shot wall that has all the humps and the bumps, right? We've got a closed shape for a sink. We have a closed shape for each finished edge, okay? Right, all the radii are connected and all that. The setting we have here right now is, we'll show you, is the polylines are staying joined for each, anytime we have the same CAD layer, those entities are joined on that part, okay? If I come into the seam, you know, we could select it and we see that's a joined geometry, which actually saves a lot of time. When I used to edit in CAD and prep things, I wish this existed then, okay? So page 1, page 2, and I've got the page 3 here, okay? Then we took the CNC Saw page, and just because it didn't fit in the little box here, I put one up here, one down here, okay? So we can see the seams are separated, okay? I've got the Jeff cameo here. We've got next.
That was Denny, right?
We've got our all layers, okay? So what I'm going to show you is, this is our material offset, and this is our finish size, really close together. Let me really zoom in here. Okay, we got one, and we got the other, okay? I like to just bring this in. As you're learning the workflow, I want you to pull this in so you can see the relationship between the material offset and the final size. This isn't generally the one I'm working off of, okay? Now, right here, the larger geometry and the smaller one on the sink. This is the material offset only, okay? Often, this is what would go into a slabsmith, a Taglio T-match, Horus, any of those things, okay? If you're gonna put these onto a slab image, right? After that's done, you might bring that back and it might look something like this, okay? And this is each slab as we go to the saw, right? And notice we've got nice, closed, connected shapes, right? That's what the saw wants, okay? Over here, I've got a finished, I have the same as the all layers over here, over here, but it's mirrored. Okay, why is it mirrored? Well, because it's kind of close to what we're sending to the router. So in this case, I've got a CNC Saw page that's mirrored. And here's what we want. We want on the router to go from that larger size down to a finished geometry. And this is where I tell the system, tell your CAM software, hey, we're gonna run a Z wheel on this, and we're gonna follow this shape precisely. We'll run a T30 package here and here. We'll run the seam package here, okay? If I wanted to join this to this, because effectively they're the same, right, we could do that. And again, I'm just in CAD, right? We could just join those together, right? I might put a small radius on those corners, maybe, it depends on the shop, right? So this is optimized, right? These are optimized for what I showed you earlier, which looked like this, right? That CNC mirrored is where I got this, okay? And in just a second, again, I'll go up to styles, apply an auto style, and I have a simple one set up here that's based on the CAD layer names, and it'll automatically apply the tool paths, okay? For me, this is a long-term goal. I want to introduce this idea and have you work towards, because it will save you a ton of time if you're doing that router work, okay? So back over here, that's this, okay? So I'm gonna back out a little bit. I know it looks like a lot, okay? And I wanna pause, and see if I have any questions. Dustin, I might have Dustin jump in. Dustin, is any points that you might want to bring up here? Dustin works with us here at LPI, and he's one of the people that actually taught me a lot about Alpha Cam and kind of the newer school of router and fabrication work, right?
Yeah, first of all, Anthony, thank you. I think, a couple of main points on what we're talking about with, these auto styles and that aspect of things are, we set, it's all based off of that DXFX port layer name. So we're setting that standard in LT3Raptor. And then once you get to the Alpha Cam side and you actually run it, like kind of what Anthony said is there's a lot of perks to it. One of the big perks is, you're going to be faster at your programming and you're going to streamline it. It's going to be easier to train your guys on to program those routers and so on. So the kind of way we look at LT3Raptor is, getting all that post-processing done, including that automation, so that when you do go into the Alpha Cam, it's a lot of, either auto toolpathing with your saw and then auto toolpathing with your router and just streamlining that whole process.
Thanks, Dustin. All right, so what we'll do, so we're kind of looking at this big grid of all the files. Again, I'm gonna just kind of pop back into the folder, right? To begin with, I like to have all the folders that exist here in CAD. I have a CNC, a nesting, and the template pages. You can have all these files just kind of at a flat folder level, right? If you want to navigate them that way. I recommend starting with them in the folders, okay? Give me a second, I'm just gonna double check and see if I missed anything here. So let's hop into LT3Raptor and let's look at some of the export settings, okay? So over here, we'll go into CAD, okay? This is what we're talking about. If we go to nesting, let me start with the template, okay? Let me start with the template. There are a few ways to do this. I personally like seeing the template page if I'm not programming off of it anymore, but just using it as that visual reference of what was in the shop drawing. I like to keep the CAD layers personally, right? And have all those layers joined, right? So that's one of the reasons I like this option of polyline maintain layers, right? And I'll tell you right here, kind of the description, polyline 0 layer, and polyline maintain layers and kind of what they do, right? CNC Saw export, this is different than what we did last week, right? You could pick, hey, I'm gonna go to a saw or optimize your settings for a CNC router, right? Many of the CNC routers, maybe not all, but many of them they want a similar set of things, right? Again, this is where we see polylines maintain layers. Right. So when we go to CNC Router, kind of locks all your settings for a minute. You can hit customize. You should see it on your screen. I have my resolution doing something weird for that video, right? It hit customize and now we can edit all those settings, okay? Nesting, right? We could pick whatever machine, right, you want, okay? If you're gonna go to a slab vein matching solution, you might want to pick that because that's really the next stop in your workflow, right? It may not be, hey, I've got a Northwood or a Park or Persiani or a Baca, right? It might be, if you're going straight to your saw, that's a great place to start. But I want to introduce you to the fact that, hey, we have a scanner from Horus, or we have a Taglio, or we're going to Slabsmith, right? And these settings, often they're similar, but it's a good starting point for those settings, okay? Another one I want to talk about, and this is actually, Dustin brought this up to me. Some of the saws, you may want to use combine elements into a single line. So I don't have it in the example that we ran today, but if you ran a extended seam, it would combine a finished edge and a seam into one connected line, right? And we'll tell you over here what's happening. So this set of export folder settings. This is what gets us here, okay? Now, there's a handy thing you can do here to just keep really organized and keep this as simple as possible. Once you set up your workflow, once you test and validate that it does what you want, let's make this easy for everyone inside your team to keep everything tracked. So the actual folder names we see here, you could say, hey, I want my material offset to be, so my template pages are that's my first one, right? And maybe I want folder 2 is my, let's say Slabsmith. All right, it would actually name the folder that, okay? And you could name each folder, and then when it's exported, it just kind of keeps you nice and organized, makes it easy to teach someone, right, the process. It'll name these folders accordingly, all right? I'm gonna pause for a second. Dustin, anything that I'm missing there that you think is important?
Yeah, no, not really. I think you're going through everything perfectly. It's all just very dependent on machines, on how you guys want to organize your jobs being, we look at kind of some of the exporting folders, right? We can organize those. We can name those by machines. There's a lot of different ways we can go, especially to fit any of your guys' shop needs, because every shop runs different. I think that, the big things are organizing your files. I think that's going to help set up your engineering teams, your programmers, and define the flow of a shop.
Thank you. These are the settings that live inside LT3Raptor. There's also some settings that live outside of the software itself. That's on purpose, right? I'm going to go to templater.com, which is the same as lpicloud.com, right? And if you're an admin on your company, right, you'll have access to settings, right? So if you wanted to create settings and unify your settings, and it'll automatically download to each computer, right? We can go in here and do that. So some of those CAD settings we're just looking at the app, the vast majority of that all exists here as well, okay? And we talked about this last week, but you could click a little switch up here. This is in many of the settings, and it locks your users from changing those settings. It also pushes these settings to them. So again, a handy trick, what I used to do is I'd find a workflow that worked most of the time, right? If you're doing custom work, you have to tweak settings once in a while once you get creative. So I would push the settings to the field by clicking this box and waiting 24 hours until everyone would sync, and I'd uncheck it because I wanted to test or do something weird again, right? So use company settings, I think, is really handy, right? So we looked at these settings that exist for CAD, again, template, CNC Saw export, nesting export. Let's get into the edge style sets, right? So I touched on this briefly before. We started with the default edge styles. I call it default plus because I added one, which was text that's red, right? These are our starter colors, for lack of a better term, okay? And we see the DXF export name and some of these other settings. I'm gonna go into the machine edge style set, okay? So we have a couple extra different finished edges, right? I gave it a little bit more nerdy of a edge naming using like tooling codes, right? It's kind of confusing at first, but after everyone gets used to it, it's actually kind of nice. Also, some of the things that are in here are cutting strategies, right? So we have a regular wall that might come in, and that's going to get a Z wheel, right? This is a CAD layer name that I could auto style to. But maybe, and I'm going to switch to full screen here. I've got some countertops on order that are coming in, right? And we're going to need a little return right around this corner bead. I don't know how well you see that. if it's Google Meet, I actually need to, I can't guarantee that the edge of my camera that you see it. So, got a small corner bead here, and we're intentionally gonna have our countertop wrap this a little bit. Well, a Z-wheel's not gonna fit in that, all right? So what I might do as a programmer, okay, is that last little section of the wall, I might call it a jet wall edge, and we might finish it on a router with a finger bit and then an electroplated bit. So we can start thinking about our milling and fabrication strategies here, okay? So let's go in here. So we have an ease, a double radius, a bullnose. I'm gonna go kind of old school. They're actually kind of coming back. Let's create an, oh, it's all right, let me share. Thank you. Here we go, let me hit cancel. So again, we see all these. I'm gonna pretend add an edge style. I'll do an OG. I'm kind of forgetting what this is. There's a few different ones. We'll pretend that's the one we want. That's a finished edge, all right? And I'll make it, I like traditionally using similar colors for the different edge styles and really rely on the edge codes personally, but find what works for you and your team, okay? So this is some of the things that we went through last week. I wanna go into CAD and talk about this, right? So the Kerf is, so again, let me back out. Details and CAD, there's two little tabs up here. So if you're not looking for it, I wanna call that out. I'm in the CAD tab. Kerf is your saw blade or blade and jet kerf. This is how much space has to exist between, I know they're different colors, but between two parts on the saw. How close can they get? Well, the blade and water jet have some thickness. This is where we set this. So most of the time I'll put 135. Offset, this is your material offset. If we switch back to here, for each edge style, what is the difference between what comes off the saw, that's stock to be left behind, and what gets ground down by the router to our final size? You can set that up for each set of tools. So let's say the specs I get on that tool package wants us to take off that edge, right? Now, I found a little trick with the things that I was running. I put a little code in here that says, is it finished? Is it an unfinished? Is it a seam edge? Some of the routers, I could just use this to drive the overhead laser for aligning the parts on the table, okay? This one's kind of neat and kind of handy. If I'm importing a DXF, the DXF import layer names, put a comma between each one. LT3 needs to understand each CAD layer, right? So when you import CAD, you can pre-assign the incoming CAD layer to go to that edge style. So we saw that mapping feature when we went from one color set to another. That also works here. So we could put, you know, maybe a CAD layer coming in as OG or whatever. You could list out all those. So this speeds up the mapping between a simple and a more complex edge style set, okay? So I'm gonna pause there and see if anyone has any questions about that. Okay. At the end of the day, this stuff, it's kind of boring and kind of nerdy here, but this is the programmer's superpower, right? You can set this up once for each edge style and let the software do that repetitive work of offsetting every single edge in CAM or CAD over and over again, right? So it may feel kind of abstract, but when you come over here, this is where it'll pay off. It'll do that work for you, okay? Okay. So, if there's not any other questions about that, I guess we can keep on going, right? We're plugging on quicker than normal. So if you have questions, don't be shy, chime in. I'm actually gonna disconnect my computer here. And maybe let's make a stone tag. So I'm gonna go into LT3Raptor, come out of the settings, go to the templating tab, and let's use our mirrored page for StoneTags. So generally the StoneTags, they're designed to work on a lot of materials, okay? The adhesive's designed to be removable. The sticker itself is waterproof. There's kind of there's a kind of a balance between making a sticker really durable so a Komanduli doesn't rip a sticker off, but also when you have those parts installed, it's easy for the installer to remove that and there's no adhesive left behind. But we do our best to protect the parts, okay? So we try to err on the side of protecting the part. If you have a fragile part, some shops are using like frog tape, there's a little bit of a protective base on that, all right? But another trick that we want to show you is, well, if you do have a fragile material, or this is a suede finish, maybe I don't want to put that sticker here. Maybe we want to put it on the back. So here's a trick we're going to do, okay? I should have restarted my printer because it's doing a cleaning cycle, right? But the idea is maybe we use our mirrored page and automatically have a stone tag that's flipped over for the back, okay? While that finishes, I'm gonna pause. Let's see, Dustin, what are maybe some other settings that are useful that we could talk about here?
Well, I think the biggest part is, right, how do you organize a job? How do we set that up?
Right.
So I think, kind of like what we were talking about before was, when we looked at naming our files, setting up that perfect workflow, getting that moving through your shop. And then by naming those files, you're defining and just making it a little bit easier for the next person to pick that job up and push it to, hey, let's say the vein
for a minute?
software, whatever that is, Slapstone, T-Match, or Taglio or Horrorstone. And then depending on where the flow is going from
Dustin while he's talking.
One person that does the layout, and then is that another programmer that potentially does the saw and a programmer that does the router. How is that organized? So I think there's a lot of value in that, as well as I think Anthony, you touched base on this being the import layer names. I guess can we dive into that a little bit more and kind of see the importance of maybe we want template to stay lean and mean and have a finished edge, but maybe it's that engineering team that's going to define what is that finished edge? Is that a miter? Is that an OG? How does that kind of thing work out?
Sure. So let me. There's another trick that you're bringing up too. Like you're bringing up miters. So cleaning's almost done, I think. But let's. Another thing that's worth talking about is I might do more blade kerf on a miter. Dustin, is that something you see is pretty common? Because that miter, right? When you have your material, right, and as soon as your blade's coming in at an angle, we aren't measuring the blade by the thickness this way. We're measuring it like this. So it's quite common. What's a good number that you find a lot of fabricators are using, Dustin, on that miter blade kerf?
You know, my go-to number for let's just take a miter cut is a 1/2 inch in spacing. And you know, to point out what Anthony's talking about is if you have a miter and a miter, that blade, if they're too close, the backside of that blade is going to drag across the other miter cut. So that's why you want that spacing, and to be able to automate that is, you know, it's pretty awesome. I mean, you know, anytime we can save time, we're making more money, right?
Right. So if I go in LPI Cloud and I went into the mitered settings, we could go to CAD, and instead of that kerf being the standard number, 1/2 inch, 1/4 inch, we could make that a little bit bigger, right? And then this gap would increase. I kind of walked away from my main screen because I'm by my printer, but that's what we're talking about, right? Now it gives that larger space between each. Okay. All right, so we've got, we should have a printer good to go. So I'm gonna come in here. We've got a mirrored saw page. I'm gonna go print, countertop tag. It's analyzing really the whole job here. I'm gonna clear selection, just do the mirrored. Right, we've got all our pages here. Next, print StoneTags. And then if you're using different paper sizes, you'd select that here, okay? Print. I hit print again. And in just a second, these will get spit out here. I just put a fresh roll in here. My first tag's a little longer, but we'll see these in just a minute, okay? Okay. While that's going, I want to do this again where we take one of these jobs and we do the color remap. So I think this is the one we did last week, right? Yep, there's that straight edge. Okay, but I've got to go to the home screen to change and remap those colors. I hit the 3 little dots, or you can right click if you're on if you have a mouse and you're at a desktop, which many of the CAD CAM folks are, right? Just right here, I go edit, edge style set, machine edge styles, right? And we could say, hey, I want this to be eased. I want this to be, you know, whichever edge we want. I just made that OG edge, okay? And this is all kind of what the automatic assignment that we see here, that's based on if we go in here on the cloud, it's based on these DXF import names, okay? I'm gonna get this set of tags that we just printed. Come back over here, okay? And there we go. There's our tags that are mirrored that we can place now on the back of the slab if you have a fragile material or a like a suede finish, something like that, okay? And I'm sorry, I think a question popped up and I think I was standing over there. What was the question that you had there?
So yeah, it looks like Orlando's asking, you know, kind of how do you set up for the vein matching software? How do you line up your parts and those types of things? And actually, Anthony, if you don't mind, I'll share my screen on this.
Yes, please.
Yeah, so, you know, if we're looking at this, right, here's my drawing. You know, kind of what I would expect. I've got dimensions, we've got sinks, we've got some of those things we're showing off. My first step in the process is I'm going to create a CNC Saw page. I'm going to select the page that I want to create that out of. Now, one of the big things I do is separate seams and miters. if I'm going into a vein capturing software, I want those parts as close as possible, right? In order to ensure where that vein is moving through the countertop. So I actually set mine very small. So I set to 32 thou. So half of a 16th is that spacing. Once I do that, we'll create that guy. Oops. Let me try that one more time. I had a setting I didn't check. And as you can see, the beauty of this is how quick I can just jump in there and redo it. Now, once I've got it, as you can see, as I zoom in, there is a separation. So barely anything. So if there's a vein moving through there, there's only 32 thou of that vein that has the potential to move. So barely anything. Once I have that, I'm going to come over to nesting. And then there's basically two ways to nest, right? I can nest, say maybe a big commercial project where I don't care about vein matching. I can just nest it into quick slabs. Or in this scenario where we are going to go into a vein matching software, nesting settings, use slab for nesting. I want that to be unchecked. We're going to add material to our countertops. We're going to add material to our cutouts, and we're going to keep all of our faucet holes. I'm going to hit next. And now, kind of like what Anthony took us through earlier, we're going to select only that drawing. Once I have it here, what you're going to see is I've got overlapping geometry. So that extra material is actually overlapping into the opposite geometry. Now, what this allows me to do is when I go to that vein capturing software, now I can trust that I can take this part and move it around. But what I'm actually looking at on my screen with how that vein moves, I can trust that it's going to be there. That vein's only going to move in that 32 thousandths of an inch area. Yeah, so that's how I would handle that. I hope that answers that question.
Yeah, that's great. That's a good trick. Yeah. That way you see, you're creating that overlap digitally. I like that. Okay. Great. So we wanted to break these CAD CAM lessons into two, right? So I hope some of you had a chance to, like last week, play with the CNC Saw page. Hopefully that set you up to do that a little bit. And then after this lesson, it takes us a couple days to do it, but we'll have this on YouTube as well. Play around with these settings. If you have routers, give yourself a little bit of time to get faster, right? So someone that's pretty wise told me once that, I'm not okay with the excuse that you're too busy to get faster, right? So give yourself, all right, 90 minutes, couple hours every week to just test another component of the workflow that matches what you do and the machines and the software that you have, okay? And just one step at a time, see if you can automate one extra piece of your workflow, okay? And in a couple of months, you will be reaping the rewards of that time investment in yourself, okay? So I do want to recap some of the things we talked about today, right? CNC saws and CNC routers, they want different information, all right? And with LT3Raptor, we're automating the creation of the files that each step in your workflow wants, okay? We took away kind of those straight seams, a little bit more of those simplified seams. We added Euro seams today. We did some advanced edge style settings with kerf and offset. And we used CAD layers. Right? We showed how you can name CAD layers that can drive some more advanced automation, including auto style and those types of things. We did create a CNC Saw page, but we mirrored it and we sent that to the routers, right? In the US, North America, we tend to mirror for the routers. Other parts of the world, they finish face up, so don't mirror there, of course. We did explain the kind of the differences, and I know it kind of looks like a lot, but I'm actually going to switch back into the screen one more time. I wanted to show all the different types of outputs. But the truth is, I want you to only look at something like this in the beginning. Really, the ones that you use are material offset for your saw, and the CNC router page. Those are the two workhorse drawings in your day-to-day work. But in the beginning, I want you to look at the relationship between the different ones, right? So you can see how they work. I have had shops that like to make a process of pulling in the all layers just so they can see what the geometries are doing, especially for work that's a little bit more complex and a little bit more custom. They want to see both of those in there. Okay. We went through, so again, you have the template pages, we have the CNC router page now that's mirrored, and we have the nesting exports. The options that exist are the finished, material offset, which is key, the all layers, the finished mirrored, and the all layers mirrored. So we have had a couple fabricators that were taught by their machine fabricator, hey, I want that outside perimeter of that saw geometry. I want that to be shown on my overhead laser on the routers, right? You can do that with the all layers mirrored. Use your material offset. You can paste that on to your router work, okay? And the last thing we did was we print some mirrored StoneTags, right? You can put those on the back of some of those delicate slabs, right? So again, we want you to kind of test your workflows, invest a couple hours a week. I really do think that's going to pay off in the long run. Now, LPI we don't make your CAM software, right? So officially, we want you to use any guidance from your machine manufacturers about anything specific about your machines. We just today want to show you a bigger toolbox, right? With a bigger toolbox, you can probably optimize your workflow, right? And about the, automated CAD to toolpath options, they're CAD layer based. It really can save you some time, but it's a good goal to work towards. One other thing I'm going to do is show you. We are here to help. Right, so I'm going to pop back into the software here. It's built right into our system. Right, we can go to help, support, and our phone numbers are right here. Right. We care about making sure that if you have a question, we get that question answered and you're off to the races and being productive. Also, right, the nesting and those things, there's a lot of different things that we want to hear about your feedback. So I want to show you another tool real quick. Contact LT3 support team, right? If you go in here and if you're in a job, you could ask a question about the job. Okay. Provide feedback. Hey, I really like what your nesting's doing. Wouldn't it be nice if I could do this, right? And if it's something a little bit more technical like that, I would recommend let us know what kind of machinery and software you have in the description here. And when you hit send, it sends a package, including your job. It kind of gives us some context of what it is you're trying to do so we can be better informed about the future development of the software and new things that we want to put in front of you. Our goal is just to make the best tools possible for the work you guys are doing every day. And in the off chance you find some glitch or something, report a bug. We want to fix those things ASAP, okay? Okay, any last questions? Todd?
Yeah, in your example where you're showing switching to an OG edge there, do you have anything built in? Can you hear me?
Yeah, I can hear you.
I can hear you.
Do you have anything built in that would automatically offset the splash length for a profile at the front or predict which piece of splash would go in front of the other to do an offset on the backside?
Great question. So if this was an OG edge, right, the extent of that OG edge here, for example, would be a certain amount, but the top of the traditional OG, let's say that might be here, right? Short answer, no, we don't. Here's the why behind it. We have some fabricators that feel really passionate. I want every splash to be pre-cut and shorter. And we have some other fabricators that want every splash to be 2 inches longer for installers, usually an install helper, to cut to fit in the field. We don't have an automation for that because the software doesn't intuitively know that yet, or I don't know if it would, right? Right now, the best thing to do is just, if you know what that is, offset the length of your splash one way or the other. I used to do something where I would leave, especially full heights, and I know, Todd, you do a lot of vertical and full heights. If I had to bring, let's say, the length of this splash in for some reason, I leave a line showing where I moved the cut line, if that makes sense. It might look something like this. I'll hit V to revise a color. Doesn't really matter which one. I'll go like this. Okay. I'll hit C for color again, go to splash. I'll hit O for offset. If this is a 3cm, I'll do a offset it this way. F for fillet. I like leaving a trail of breadcrumbs for others to know behind, right? Anytime you have one material interacting with another, there's always a chance that your slab thickness, at least when I'm in the field, I assume it's a nominal typical slab thickness. But sometimes it's it's a Taj Mahal or whatever, and it's not the slab thickness I imagined in the field. And a programmer now knows what we did and can adjust accordingly. We had a lot of success doing that with measuring full height splash. And when you're trying to do full height splash and countertops at the same time, that's a common variable you've got to control. So short answer to your question, no, we don't automate that, but I think this is a really useful tool to communicate between the field template and production, some of those design details, okay? Any other questions before we wrap up? All right, well, I think in just a minute, we're gonna probably stop the recording. I'll hang out for another few minutes after that. But ultimately, we really appreciate you taking your time out of your day to hop on here, look at the tool set that's available. We do really want to hear feedback, so help, contact support team. If there's things you like or want in the nesting engine, what does that look like? We really do track all of this information, right? So think of this as a simple way to kind of vote for the features and things that you want. We really are trying to hear what everyone has to say, what you're doing, again, just to make the product a little bit better with every release that we do, okay? Stay tuned for upcoming release. We're centering a lot of features around just general communication between the field and the office, back to the field, and we'll do another group training hopefully soon about some of those new features, all right? Well, everyone, I appreciate it. Thanks for your time, and don't hesitate to reach out to us. I hope you all have a great day.